Hi, Ari. How are you?
I'm good.
Oh, good. Are you sick? Are you okay? We'll wait a few more minutes. Hi, Brandon. How are you? Hi, Gina. So I shouldn't show my face because I'm not feeling so great today, but I wanted to still at least have class. So I'm going to be drinking lots of tea so I can keep talking. So I apologize for having to do it this way, but there was no other way to do it. So I hope you guys had a good week. So I'm going to go ahead, excuse me, I'll wait a few more minutes. Hi, Mark. Okay. So I know there's going to be a few that aren't going to be here today just because having to go in between and classes and home and all of that. So what I wanted to do is I just wanted to at least keep us rolling in this new section. And this section isn't too bad as far as the algebra part goes. So what we're doing is we're coming into chapter 11. Excuse me, and chapter 11 is kind of the apex, if you will, or the top of this class. And so what we're doing is we're getting to the point where we're going to be able to find optimization. So in business, to optimize means, you know, you want your maximum revenue, your maximum profit, and you want to minimize costs. So whenever I talk about optimization, that's where we're going with this, is we're looking for the highest or the lowest value. And mathematically, it's the exact same thing. We're just looking for the high value or the low value. So as we begin working in this, excuse me, the first thing we're going to look at is first derivatives. And so I wanted to make sure that you have these word connections. So anytime we're looking at first derivatives, you're looking at slope, which is what we've been doing. And now we're going to introduce critical numbers or critical values. And the critical values or critical numbers are going to take us to a test chart. So if you can look at this as kind of a progression of terms, and they all mean first derivative. That means that's how we're going to find all of these values. So when we're looking at this particular graph, if you notice right here, you have a high point. Okay, so this could be considered a maximum. Now you're going to see terms like this relative maxima and relative minima. And all that means is we don't have endpoints yet. We'll get there where we're going to have endpoints. And so maxima or minima is just another term for maximum or minimum. So high or low, that's what we're looking for. Okay, so in this case, when we're talking about relative, we don't have endpoints yet. So we're just kind of looking at a graph. It goes up and down. We're looking at where does it go up and where does it go down. Okay, so when you look at this, if we look at question 1, it says, at which of the points labeled on the graph does the derivative, so the slope, change from positive to negative? So remember, when we're looking at derivatives and we're looking at slope, remember this is considered a positive slope. Okay, so if I'm looking here, if I run along this graph, even though it's very steep, it is a positive slope. And then it gets to this point right here and it changes. So it's positive on this side. And when I get to this side, it changes to a downhill or a negative slope. So what we're doing is we're looking at these points right here. where does it change? Where does it go from positive to negative? So in this case, it goes from positive to negative at the point -2.6. So this would be considered a critical point because it went from up to down. Now this point right here, if you notice, I'm going to change colors. If you notice, the slope is going downhill here. It hits this point and it kind of, the steepness is not quite as steep as the first one. And then it continues downhill. So there's no critical point here. There's no point where it changes from positive to negative or negative to positive. It just stays on the negative track. Okay, so here we have it positive and then it changes to negative. Here, it's just continually going down negative. And then we get down here and we see it's negative on this side. It hits this point right here, and then it changes to positive. Okay, so this would be considered a critical point because it went downhill and then uphill. This would also be considered a critical point because it was going uphill to downhill. So anytime you have those changes, that's when you know, okay, this is important. Something happened at that particular point where it changed the slope. So for this one, it changed from negative to positive at the point 3, 3. Okay. And then at which of the points on the graph does the derivative have no sign change? Well, that would be right at 0, 0, 2. So it stayed negative, it hit that point, but it continued down as negative. Okay, so what I want you to grab from this is that something major happened right here. Right at that point, something happened where, so if this was my profit function, my profit was rising, it was increasing, and then something happened right here and it switched, and now my profit is decreasing. Okay, so as a business owner, you want to know, all right, well, what happened right here at this point? Or down here at my -3, it's going downhill, so my profit is decreasing. And then again, something happened right here where it turned it around, and now my profit is increasing. So as a business owner, what did I do? What happened right at this point where it made a decreasing profit go to an increasing profit? And that's what we're looking for. That's where we're going with this, is we are looking for the actual value or the actual point where things started changing. Okay, so when you're looking at this, at these functions, okay, when I have a slope that's going uphill and then downhill, when I get right here, the slope right here is a negative, as a 0 slope. Right, so it was going uphill, it hit 0, and then it went downhill. And then same thing here. I have a decreasing slope, and then again, it hit 0, and then it started increasing. So when your slope is 0, that is a super important point. Okay, and that's what we call our critical values or critical numbers, is when your derivative is 0. So that's going to be where we're going with all of this. Okay, so any questions so far? Okay, so what we're going to do is we're going to look at these graphs. Okay, so, and we're going to match them. So these are what's called test charts. So these are going to be super important for us to be able to read and create, is a test chart. Okay, now because this is a first derivative, what these minus and pluses mean is, a minus means your slope is going downhill. So I would prefer, it helps because it helps you be able to visualize what the graph is doing. So when you have a negative slope, that means your line is going downhill. When you have a positive slope, that means your slope is increasing. Okay. Hi, guys. Okay, so any questions on that? When you're looking at the minus sign, that's a negative. When you're looking at the plus sign, that's a positive. Okay. All right, so what we're going to do is we're going to match these. So if you notice, they're all threes. That's our what's considered our critical value. Something happened at 3 on every single one of these graphs. Well, some of them you have a 0 and some of them you have an ND. So when you have a 0, that means you have a horizontal slope. Okay, that's what 0 means. ND means it's a vertical line. Okay, so ND means not defined. So if you remember the vertical, if you have a vertical line, you have an undefined slope, and that's what that means. All right, so just to get you started. So on A, I'm looking at a slope that goes downhill. It has a horizontal slope at 3, and then it switches and goes uphill. So when we look at these, so here on 20, I'm going downhill and then I'm going uphill. So that could be an option, but if you notice, if I have my slope and I'm coming down here, my slope ends up being vertical. Okay, so this would be considered ND. We are looking for when a slope has 0 for A, when our slope has 0. Okay, so does anyone see it yet? So look for a decreasing slope and then a slope that goes to 0 and then an increasing slope. Okay, so if I look at 19, that's increasing. So I know that that's out. I look at 23, that's also increasing. So I know that's out. 24, I do have a decreasing slope, but when I come here, it becomes vertical again. So that's going to be your undefined. So 24 is not one. Anyone see? It's one of these 4, one of these bottom 4. Anyone see it? I like face-to-face so much better. Nobody sees it? Nobody wants to venture a guess? I narrowed it down to the last 4 for you. Here's decreasing. And then it goes to a 0 slope, but then it continues to decrease on 22. Let's see. 26. Yes, Brandon, good job. Thank you for answering, Brandon. Okay, so here's what you're looking for. It is decreasing. So it's decreasing. Then you have a slope of 0, and then it increases. Okay, so it's going down and then up again. So down, 0, and then up. So this one is A. Okay. And then B, we're going to do the same thing. It's decreasing and then it's increasing, but at 3, it is undefined. So you're looking for a vertical slope on B. So this one is not vertical. These 2 are vertical because your slope is going to come up and then it goes to vertical like that, and then it goes down. So this one could be an option. This one is vertical, but you have a slope that is going downhill, right? It's going downhill, and then there's your vertical, but then it continues downhill, so that's out. Anyone want to guess for B? Okay, Brandon says 20. Okay, so let's try it. So we have it downhill, which is what we wanted, and then it goes to vertical, which is what we wanted, and then it goes uphill, which is what we wanted. Good. So this one is B. Okay, so what we're doing is we're creating these test charts. We're reading these test charts to make sure that they fit our scenario. So what we're looking for is, where do things change, right? So on A, it went downhill and then it went uphill. Well, if you notice on number 26, you see how it goes downhill and then uphill? This point right here would be our minimum. Okay, so that's what we're looking for. We're looking for the lowest point or the highest point, and it will happen when you have a zero slope. Okay, so what about C? C is going uphill, hits horizontal, zero slope, and then it goes uphill again. Does anyone see it? So on 19, if we're trying, we're going uphill, it hits zero, so we're good so far, but then it starts going downhill. So 19 is out because that one has a switch in it. 23 is a vertical, so we know that's out. 24 is also vertical, so we know that is out. 21 is vertical right here, so we know that's out. So let's try this one. So we have uphill, we have uphill, and then horizontal, and then uphill. So 25 would be C. So what you, let's see. Good, Jake. The chat doesn't pop up until I open it. Okay, so what about D? So D is uphill, and then a vertical line, and then uphill again. So Jake, ND means undefined or not defined. Okay, so 21, let's check it out. So we have uphill, which is good, and then we hit our vertical, which is the undefined, and then uphill again. So 21 is D. Good, Timothy and Nick, or Jake. Okay. Okay, so we got the uphill ones. Okay, E. So E, we have uphill. It hits a zero or a horizontal slope and then goes downhill. So what do you think it is? Okay, so let's look at 19. 19, we go uphill, hits a zero slope, and then it goes downhill, which is exactly what E is saying. Uphill, hits a zero slope, and then downhill. So 19 is E. And then if you notice again, so if you notice again, when it goes up, hits a high point, and then down, this is what's called a maximum. Okay, so you want to notice, okay, it's going up then down. Well, if I do it with the arrows, you can actually see there's your increasing slope. It hits a high, and there is your decreasing slope. And that maximum or the minimum, it happens when your slope is zero. Okay. And then F, which one do you think is going to be F? So remember, ND is undefined or a vertical slope. So it goes up, hits a vertical, and then down. What do you think? $23. Okay, so up, hits a vertical and down. Very good. So this one's F. Good job, Dante. Okay, so again, with the arrows actually help you see it. So this is also showing a up and then down movement, up and then down. And so that it would be a maximum. Okay, and then the last two, you only have two more to go. So it's going downhill, hits a vertical, and then downhill again. So here's downhill, hits a vertical, which is undefined, and then downhill again. So down, and then it just keeps on going down. Okay, so this is G. And then downhill, hits a horizontal, and then downhill. Okay, so this is H. All right, so what we're going to do is we're going to put all of this together. So when you're looking at these, you're looking for critical points, and those critical points are when things change from uphill to downhill or downhill to uphill. And the critical points happen when your slope is 0. Okay, so that's where we're going with all of this. So here we go. So what we're going to do is we're going to sketch a graph. Okay, and again, what we're looking for are the critical points. So remember your terminology. First derivative means you are looking for your critical points, and those critical points are going to give us the max or the min. Okay, that's what you want to kind of all put together, is the critical points are going to give us the maximum or the minimum. And so this is a little bit different than what you've been doing, because really the only derivative rule that we're going to use is our power rule. So when we're walking through these, we're going to walk through a series of steps. Okay, so the first thing, we're going to find is the domain. And remember, the domain are just the X values. So in what we're doing here, the domain is the domain or all the X values that I can use for a polynomial. So my first step is the domain can be all real numbers or from negative infinity to positive infinity. When we start looking at very specific word problems, like maximum profit, minimum cost, we're going to have a domain. We're only going to look between maybe 1 and 15 because we don't want to have to look at an infinite number of numbers. Okay, then the next step is we're going to find the derivative and the critical numbers. So that means you're going to set the derivative to equal 0. Okay, that's always going to be how you find the critical values or the critical numbers. So I'm going to do this as we go. The domain for any polynomial is all reals or negative infinity to positive infinity. You can say it either way. And then for the next step is we're going to find the derivative. Now, the reason why we're finding the derivative is because we're looking for where the critical numbers are. Critical numbers only happen when the derivative is 0. So you have to find the derivative first, which is just your power rule. So this is all second nature to you, right? Drop the 3 in front, subtract 1. Drop the 2 in front and multiply, subtract 1. Drop the 1 in front, subtract 1, and the X goes away. And now the critical numbers, I'm going to set my derivative to 0. Okay, so I found my derivative using the power rule. Now I'm setting my derivative to 0. And so if you remember from the very beginning, I said, you have to know how to factor in this class. And I will never say, now you're going to factor. Now you look at this and you go, okay, I have a trinomial that's set to 0. That means I have to factor it. I have to find out what X is. Okay, so I'm going to factor a 3 off because that's in common. And now, if you remember, this is how I learned it. So however you learned it, I'm going to multiply to get -3. I need to add to get 2. So 3 times -1 is -3. 3 plus -1 is +2. So I have x plus 3, x minus 1. And remember, the 3 is still out here. That's still going to be important. Okay. So now I can solve for my x values. So 3 is just 3. X plus 3 equals 0. So x is going to equal a -3. And then x minus 1 equals 0. So x is going to equal 1. These are my critical points. Okay, that's how you find your critical points. You set your derivative to 0, and then you solve. And usually you will be factoring with these. Factoring, or if it's a quadratic, you can use the quadratic formula. Okay, so we're done with A, we're done with B. Now C says we're going to draw a sign diagram or a test chart. So now we're going to go back to what we were just looking at. Our critical points are at -3 and 1. And what we're doing is we're testing to see what is happening with our slope. So notice I mark this as a derivative, okay, because this is going to tell me, okay, I'm going to use the derivative to test this. The good news about this is you don't have to plug values in. I don't care what the value is. All I care about is the derivative or slope positive or negative. That's all I care about. So what I'm going to do is I'm going to test in these intervals. So I'm going to find numbers in this interval. And once I know what the number is, that means in that whole interval, my derivative is going to do the same thing. So I can use any number I want that's in this interval right here, anything less than -3. I can use -4, I can use -5, I can use -10, I could use -1,000. It doesn't matter, because in this interval, my slope is going to be doing the same thing. So here's where it doesn't matter what the numbers are. All that matters is what sign am I going to get when I plug my numbers in here. Okay, so watch what I do. 3 is a positive. When I plug -10 in here, I get -10 plus 3 is a -7. Don't care what the number is. When I plug -10 in here, I get -10 minus 1. That means the whole thing's going to be negative. So a positive times a negative means that whole thing is positive. So in this interval, I have a positive slope. That means my slope is going to go uphill. Okay. And all I'm doing is I'm plugging this into my factored derivative. Okay, now I could plug it in here. I could plug it into this derivative, but then I have to calculate numbers. 3 times -10 squared is 300 plus 3 times negative. So you can see it can get really messy. If I use my factored form of the derivative, then it's super easy to find out if it's positive or negative. This 3 I need, that's positive. -10 plus 3 is a -7, so the whole thing's negative. -10 minus 1, the whole thing's negative, and then I just multiply. Positive times a negative times a negative makes the whole thing positive. Okay, so now I'm going to do the same thing in this interval. Pick a number between -3 and 1. I'll use the same color. Anytime I have a negative to a positive, I'm going to use 0. Makes my life easy, right? 3 is positive. 0 plus 3 is positive. 0 minus 1 is negative. That makes that whole thing negative. So it's going downhill here. Any questions so far? So now I'm going to find out, pick a number in this interval. And again, notice I'm using the derivative. So I'll pick 2. I can pick any value I want. So the 3 is positive. 2 plus 3 is positive. 2 minus 1 is positive, so that makes the whole thing positive. So it's going uphill here. Okay, now you can visualize this. Do you see how the slope is going uphill? Then it turns and goes downhill. Then it turns again and goes uphill. Whenever you have up, then down, that means this -3 is my maximum. When it goes down and then up, that makes the 1 my minimum. Okay. Any questions so far? There is a process that you need to go through. Okay, so we have our sign diagram. That's what this is. It went up and then down and then up. So I know I have a maximum and a minimum, and that's where you're going to evaluate. So D is you're evaluating at the original function, no longer the derivative, because you want to know where exactly on my graph is my maximum and where exactly on my graph is my minimum. So if my maximum happened at -3, I want to know where on my graph is that negative. Now, if you notice, it says sketch, right? It doesn't say do an exact sketch. It just says sketch it. So I know at -3, I'm going to have a maximum. So when I plug -3 into the original function, make sure you watch your signs. You get -27 plus 27 plus 27 minus 11. So my 27s cancel, and I have 27 minus 11, which is 16. So my maximum, and again, it's a sketch, my highest point is y equals 16 at x equals -3. That's my highest point. That's my maximum. Okay, so when you're doing this evaluation, remember you're evaluating at the original function, and we're evaluating only where there's a max and where there's a min. So I'm going to evaluate at 1. So I plug that 1 back into my original, always back into the original. So 1 plus 3 minus 9 minus 11, and I get -16. So at 1, I have a point down here at -16, and that is my relative minimum. Okay, now between the maximum and the minimum and my test chart, I can sketch this really easily. Everything less than -3, I have a slope that's increasing. So I know my slope is going to go up. It's going to hit this maximum. It turns, okay, it hits the maximum, and now it's going to go downhill. So it turns and starts heading downhill. I hit my minimum down here. It turns again and starts going back uphill. Okay, so you can always see what your graph is doing. Here's my increased slope. There's my decreasing slope. And here is my increasing slope. Okay. And that's it. So you can see there's definitely a process. The process gets faster and faster the more that you do these, but it does get easier. The other thing is when we get into the next section for second derivative, we're going to walk through the exact same process. So you're going to do the exact same process twice, once for the first derivative and once for the second derivative. Okay, any questions so far? All right, so now I need more room. Let's see. This is why I like my whiteboards too. Okay, so let's try it again. We're just going to walk through the process. So the first step, because I have a polynomial, it's all reals or from negative infinity to positive infinity. That's my domain. So we're always going to have to establish our domain. The next one is we are going to set our derivative to 0. So we're going to find our derivative. So using the power rule. Okay. Then we set our derivative to 0. And remember, the reason why you're doing this is because you are looking for critical points. You're looking for where does your graph go up and down. So I have 3. I'm going to factor out a 3. And I end up with, this is the difference of 2 squares. So remember, factoring is always going to come back to haunt you. Okay. And now I'm going to set each of these to 0 and solve. So I get x equals -2 and x equals +2. Okay, so again, all I did is I set both of those to 0 and solved. Okay, it's just the opposite sign. So as soon as you find these right here are your critical points. And these are what you're going to use to set up your test chart. So I always label it because we are going to get to the point where you have first derivative and second derivative. Okay, so the critical points are what goes on your test chart. And then you are going to look in your interval. Okay, you're going to see what is my graph doing in this interval. So checking my derivative. Okay, so I come back to here. Remember, you're going to come back to what you factored. So the 3 is positive. Then I'm going to put, I'm sorry. Yeah, the 3 is positive. I'm going to put -4 in here. So -4 plus 2 is a negative. -4 minus 2 is also a negative. So positive times a negative is a positive. The other way, remember, that you can do this is just count your negatives. I have an even number of negatives, which makes this positive. So I know my slope is going to go uphill in this interval. Then I'm going to test in between. So again, I have a negative to a positive, so I can use 0. The 3 is positive. 0 plus 2 is positive. And 0 minus 2 is negative. So now I have an odd number of negatives, which makes this go downhill. And then I'm going to check in the third interval. So anything above 2. So the 3 is positive. 4 plus 2 is positive, and 4 minus 2 is positive. So this whole thing is positive. So this interval goes uphill. Okay, so once again, I have a maximum because it went uphill and then downhill. And then here I went downhill and then uphill. So this is my minimum. Okay, and you should be able to visualize it. It goes up and then down and then down and then up. So there's your maximum and there's your minimum. Okay. And now I have to find out for my graph where exactly is the maximum. So this is where, remember, you go back to the original. So -2 cubed minus 12 times -2 plus 2. So -2 cubed is -8 plus 24 plus 2, which is 16, 18. So I have a maximum at -2, 18. So that's my highest point. And then my minimum is at +2. So we have 8 minus 24 is -16, plus 2 is -14. So at +2, I have a minimum at 2, -14. Okay, so again, looking at my graph, it's an increasing slope, it hits my maximum, then it's a decreasing slope, it hits my minimum, and then it starts going up again. Now notice I don't care where it crosses the y-axis. I could find that out really easily. Right there is my y intercept. So I could make this, you know, a little more accurate. I come uphill, I hit, it crosses at 2, it hits the low and then crosses again. And we're going to pretend like this is just a beautiful smooth line. Okay. Everyone good? Okay, we'll do one more. So this one, if you notice the first two, your first term was x cubed. Same thing here, x cubed. And if you notice, when you have a cubic function, you have kind of an S shape where it goes up and then down, or it could go from down and then up. So it's always going to be kind of an S shaped when you have a cubic function. When you have a function with to the 4th power, it's going to look a little bit differently, but we can walk through the exact same process. The process is always going to be the same. It doesn't matter what we start with. It's always going to be the same process. So with this one, separate all of this mess. With this one, again, domain is always first. So because we're just dealing with polynomials, it's going to be always the all reals. Once we get into the word problems, you'll see where the domain comes in more into play. Okay, and then the next step is we're going to find our derivative. So using the power rule, the 4 gets dropped to the front, so it's -4x cubed. The 2 gets dropped to the front and multiplied, and then take 1 off. So there's our derivative. Then we're going to set our derivative to 0 and then solve. So this is where greatest common factor, we have a -4x in common, which means I have x squared minus 25. And all I'm doing is I'm dividing. So the way that you check to make sure you did this right is if I multiply -4x times x squared, I get -4x cubed. -4x times -25 is a positive 100x. Okay, so now again, difference of 2 squares. So I have 4x's on the outside, x plus 5, x minus 5. Okay, now this one's a little bit different. If you notice this one up here where the orange mark is, the 3 doesn't have an x attached to it. We still have to use that when we're checking for our intervals, but there's no x to it. So we only have 2 critical points. If you notice here, this -4 does have an x attached to it. So anytime you have an x, you're going to set all of them to 0. Okay, because that's how you're going to find the critical points. So if I have -4x equals 0 and I divide both sides by -4, I get x equals 0. When I subtract 5 from both sides, I get x equals -5. And when I add 5 to both sides, I get x equals 5. So now we have 3 critical points. So always know if I add 2 x's, I have 2 critical points. When I have 3 x's showing, I'm going to have 3 critical points. Okay, that's an important aspect, because a lot of times what happens is people forget one of the critical points and then it throws off the test chart. Okay, so now we have our test chart. Make sure you put them in order. Otherwise, that could also throw off the test chart. And remember, this is for our derivative. So we're testing to see, is this going to go uphill or downhill? So I'm going to test them over here. So plug in any value less than -5. And this is where I'm going to use, again, I'm going to use this factored form. So -4 times -10 is a positive. -10 plus 5 is a negative. And -10 minus 5 is also a negative. So I have a positive. So this is going uphill. And now I'm going to test in between -5 and 0. And again, you can pick any value you want. Just make sure it's in that, within that interval. So -4 times -1 is positive. -1 plus 5 is positive. -1 minus 5 is negative. So that makes this whole thing negative. Okay, so what you can see here is we're going up and then down. So this -5 is a maximum. Now I'm going to test the next interval. So between 0 and 5, I'll do +1. So -4 times 1 is a negative. 1 plus 5 is a positive. And 1 minus 5 is a negative. So I end up with a positive value. So it goes up. So again, you can see it goes downhill, then uphill. So this 0 is a minimum. And now I'm going to test this interval. Now, if I plugged in the actual value, right? If I plugged in this 5, it would take me back to 0, because that's how we got this. We set it to 0. So don't ever use these values to test the interval. You have to use in between, either the higher or the lower values. Okay, -4 times 6 is a negative. 6 plus 5 is a positive. And 6 minus 5 is also a positive. So the whole thing is negative. Okay, so I went up and then down. So with this one, I have 2 maximum values. That's what's considered a relative max, because it's within the range of the domain that we're in. And so we have 2 maximum and 1 minimum. And that's okay. All right, so last step. We know we have to find where exactly on our graph is our max and our min. And so we have at the original function, which was, be careful of your negative signs. Move this over a little bit. Okay, so remember, there's an extra negative here. So there's 4 negatives plus 1 more. That makes an odd number. So the whole thing is negative. 5 to the 4th power is 625. 5 squared is 25 times 50 is 1250. So our max is, one of the maxes is that spot -5 and 625. And we're going to plug in our minimum of 0. So we have 0 to the 4th plus 50 times 0 squared, which is all 0. And then we're going to find out how high is our, we're at +5. So we have 5 to the 4th is 625 with 1 negative in front. And then again, it's 1250, so 625. So our graph is going to look like this. At -5, we have a max of 625. Oops. We have a minimum at 0, 0. And then we have another max at 5 and 625. Okay, so looking at our graph, you can see it goes uphill, it hits the 5, it goes downhill, it hits the 0, it goes uphill, it hits the 5, and it goes downhill. So that's the basic shape that our test chart is. So it goes up, it hits a max, it hits our minimum, it turns again, hits our max, and then it turns and goes downhill. And that's the basic shape of anything to the 4th power. It's got this M quality to it. Okay, all right, any questions? I'm going to stop there. Any questions? So just remember with this one, it's a little bit different as far as like the techniques. But what you want to keep in mind is you're looking for where is the highest point and where is the lowest point. That's what you're looking for. Okay. Okay, I'm going to stop there. My voice is killing me. My throat's killing me. So I am planning on being there Wednesday, and we'll do a couple more on Wednesday, and then we'll jump into the second derivative, and then we're going to put the first and the second together. Okay, thanks you guys for showing up. I really appreciate it, and I will see you on Wednesday. Hey, Timothy.